Greetings, mathematicians. We have the warm-up. So using the formula F equals 9/5 C plus 32, find the following temperature conversions. So this is relating Fahrenheit and Celsius. So number one, what Celsius temperature is equivalent to 32 degrees Fahrenheit? All right, so I see 32 degrees Fahrenheit. So I'm going to go ahead and plug in 32 for F into this equation. All right, so I'm going to go ahead and do that up here. So we have 32 is equal to 9/5 times C plus 32. All right, so going ahead and solving for C, I need to isolate that, meaning that I am subtracting off 32 from both sides. Those cancel out. 32 minus 32 is 0, is equal to 9/5 times C. All right. So a few things that I can do here. You might have seen, right, I can multiply both sides of the equation by 5 to clear out that fraction, or I can multiply by the reciprocal. I'm going to go ahead and multiply that reciprocal, so 5 over 9, to get that cancellation. Okay, so on this right-hand side, I am just left with C equals 5/9 times 0 is just 0. So the equivalent that's equal to 32 degrees Fahrenheit is 0 degrees Celsius. So we have 0 degrees Celsius. Which makes sense because 32 degrees Fahrenheit, that's the freezing temperature of water. Celsius is based off of that as well. So 0 degrees Celsius, that is the freezing point of water. All right. Number two, what Fahrenheit temperature is equivalent to 225 degrees Celsius? All right. So now I know that my degrees Celsius is 225, and I'm going to go ahead and plug that in for C, and then we're solving for F. All right, so again, I'm going to go ahead and use that upper left-hand corner for that. So let's do it. We want to solve for Fahrenheit, which is F, and that is equal to 9/5 times C, which in this case is 225. And then we have plus 32 according to that equation, all right? So simplifying, we have 9/5 times C, which is 225. That is F is equal to 9/5 of 225 is 405 plus 32. Adding those together, I get a final temperature of 437 degrees Fahrenheit. So number two, we have 437 degrees Fahrenheit. Fahrenheit. Difficult word to spell. All right. Number three, what Celsius temperature is equivalent to negative 40 degrees Fahrenheit? All right. So I'm going to go ahead and erase my work. So we have this. Let's go ahead and take that negative 40 and plug it in for F. All right. So again, we're solving for C. So I have negative 40 equals 9/5 C plus 32. Okay. So again, I have to isolate C. So I'm going to go ahead and subtract off 32 from both sides. Those cancel. Here I am left with negative 72 equals 9/5 times C, right? And again, I can clear out those fractions by multiplying both sides by 5. I'm going to go ahead and do that opposite reciprocal again. So 5/9. So when I go ahead and multiply that, I have 5/9 times negative 72. That gets me negative 40 is equal to C, right? So these cancel out, I'm left with C. Therefore, what Celsius temperature? It is equal to negative 40 degrees Celsius as well. So we have negative 40 degrees Celsius. So just by chance, negative 40 is that break-even point where Fahrenheit and Celsius are the same thing. All right. So, learning target 10, function attributes. our essential questions: what is the difference between a relation and a function? And what does the domain and range represent? All right, so some vocabulary for you. We have the coordinate plane. That's just two real number lines that intersect at a right angle. And then we have ordered pair. So each point in the plane, that corresponds to an ordered pair. And we always write that as parentheses, x, comma, y, and parentheses. All right. So while this loads, right, make sure that we're paying attention to detail. So we have those parentheses and all that good stuff. All right. So here we have that coordinate plane. We are going to label all the points of interest, right? So this point right here is called the origin, and that has an ordered pair of 0, 0. We have this axis right here, which is called the x-axis. It is the horizontal axis. It is all your x values. Okay? The vertical line, the vertical axis that we have here, that is called your y-axis. Okay? Then we have quadrant 1. It starts in the upper right-hand corner here, and then we actually go counterclockwise to fill in the rest of the quadrant. So we have quadrant 1, we have quadrant 2 is the upper left, quadrant 3 is the lower left, and then quadrant 4 is the lower right, right? And what this means here, right, so this plus plus, this is my x-coordinate, this is my y-coordinate, right? So this is just telling me that I have a positive x-coordinate and a positive y. This is telling me I have a negative x-coordinate and a positive y. Negative, negative, and then we have the last positive and negative. All right, so we need to go ahead and we need to plot these points, right? So let's do it. So if I want to plot the point 3, 4, I start at the origin, I go right 3 units, right? Go along the x-axis to 3, and then we go up to positive 4, and we plot that point. That's it. That's plotting a point. Okay? I'm going to go ahead and pull up those next two, and we want to go ahead and plot those points as well. Okay? So we're going to plot -2, -3. Always travel along your x-axis first, so I'm going to over to -2, and then I'm going down to -3, and I'm plotting that point. Okay? So that is the point -2, -3. Let me go ahead and pencil this in. So we have 3, 4. This is -2, -3. And the last one we have is 2, 0. So again, I'm traveling along the x-axis. We're at 2. 0, that means that we don't rise at all. So that is my final answer. We have 2, 0. All right. And let's see if the animations match up. So that is 3, 4, -2, -3, 2, 0. That looks great. All right. More vocabulary. So a relation is just a pairing of numbers in one set, often called the domain, with another set. So that is called the range. All right. So our domain, x values, input, independent variable, those are all related. And then we have a range, which is the y values. And it also goes by output value or dependent variable. So if I'm looking at this table, we have the left column, which is our x values, our inputs. And if I'm looking at the right-hand side, we have our outputs or the y values, right? So if I'm handwriting this, I like to go ahead and I like to write, I usually just stick with D for domain. And we have a list of numbers here, right? So to identify that, we use a curly bracket. And I start from the smallest number and go to the biggest number. So we have 2, 4, 5, 6, and 7. So 2, 4, 5, 6, and 7. And I like to separate them with commas. All right. And then for the range, same thing. I use the letter R for range. And we just want to write from least to greatest. And if there's any repeats, we don't write them twice. So we have 3, 5, 6 is repeated twice, but I only put it down once, and then we have 9, and end curly bracket. So that's our domain and range. Let's check the animation, make sure it looks good. That looks great. All right, your turn. So give the domain and range of the following relation. So domain, you're just looking at your x values. Range, you're just looking at your y values. So we have 3. Okay. I went ahead and I clicked through those answers. So again, your domain is just your x values, your range is those y values, and then make sure that you're using those curly brackets to indicate that we are just interested in those specific values. All right, now we're going to go ahead and we're going to look at functions. So a function, that just means that for each input, there is exactly one output. All right, so if I'm looking at this function right here, right, this is a function because if I'm looking at my x values, each x value has exactly one output, right? I don't really care that these 6s are repeated. We have one output per unique input, right? So that is an example of a function. This table over here is not a function because I have these 5s repeating, right? And if I look at that output, right, this 5 has an output of 6. This 5 has an output of 7. Those are different outputs. So it's because of that, this is not a function. All right. And vertical line test, it's related to functions. So this is used to tell whether a graph is a function or not. Okay. So if I draw a vertical line on a graph, if it passes through more than one point, it is not a function. Okay. If that's not the case, then it is a function. All right. And this is a pretty simple one. The definition is a little bit tricky, but all you do is you're looking at your graph, right? So here we have our graph, and I'm trying to make sure that I can draw a vertical line. If it passes through more than one point, it is not a function, right? So if I draw a vertical line here, so far it passes that vertical line test because it only passes through one point. But if I draw the vertical line anywhere else, so for example right here, that vertical line passes through more than one point, meaning this is not a function. So since it passes through more than one point, this is not a function. Right? I'm looking for this to fail, right? This is not a function because it passes through more than one point. Here's another graph. So again, I'm looking for, are there any points that are stacked directly on top of each other? So if I draw a vertical line right here, so far so good. If I draw a vertical line over here, kind of silly, there's no points, but so far so good. And if I draw one here, it's fine. But if I draw that vertical line right here, it passes through more than one point. So again, this is not a function. All right, looking at this graph, let's try it. So if I draw a vertical line here, it is fine. Here is fine as well. It looks like no matter where I draw a vertical line, it only passes through once. So this is a function. All right, so now we can look at more graphs. It kind of looks like a linear equation to me. Let me see if it is a function, right? And we're just gonna go ahead and do the same thing. I can draw vertical lines anywhere I want, right? So here it only passes through once, here it only passes through once, here it only passes through once. That's true for all of them, so this is a function as well. It passes the vertical line test. Let's try another one. So here's like a semicircle. Let's check if that passes the vertical line test. If I draw a vertical line, let's try it right here. So that's not a perfectly vertical line, right? But let me try that again. So if I draw a vertical line, okay, it passes through 2 points. It passes through once there and twice there. that does not pass the vertical line test, so this is not a function. So this is not a function. Okay, last one. This looks like an absolute value equation to me. Let's check if it's a function, right? So again, I can draw that vertical line anywhere I want. It looks like it only passes through there once. It looks like it only passes through there once. Passes through here once. No matter where I draw this line, it always passes. Therefore, this is a function. All right, and that's it.